So now we have our next speaker. So Josh is here. Josh is from Civo. He's the Chief Innovation Officer. I just really like that title. That's a really great title. So let's add Josh to the screen. Welcome, Josh.
Don't forget to unmute yourself, Josh.
Mm-hmm. Yep.
We're still saying that in 2023. Yeah, cool. Well, thanks for joining us. We are going to duck out, give you the floor, and Josh is going to stay around also to moderate an amazing ML AI panel. So make sure you stick around for all that goodness. Thanks, Josh.
No problem, and thank you for having us today. It's been fantastic to see so many different talks on today, and I think the wide degree of disciplines that have been spoke about. I'm really excited to talk to you guys today about machine learning in a cloud-native context, and actually how this is transformed very much so recently, and there have been some challenges around launching successful machine learning projects. We'll try and keep it at a relatively high level so it's understood by all, but the hopes for the end of the session is you'll understand what makes a successful machine learning project. You'll understand the gotchas that cause a machine learning project to fail. You'll see some of the recent pivots that the ML industry has been undertaking and how that's affected the way that you can build machine learning. And we'll also review some of the common misconceptions and do some expectation versus reality on the current state of machine learning. I've kept this quite a high level, but I'm not afraid of any of the technical questions towards the end. So we'll save some time for questions, and I'm happy to grab those en masse as well as we go. So to start out a little bit about myself, as mentioned, I'm Josh. I'm the Chief Innovation Officer for Civo. We're a cloud-native services provider focused on giving a developer-first experience, focused on a Kubernetes-based cloud computing orchestration. We're really passionate about making sure that our stuff feels really good to use and is also much simpler than the hyperscaler solutions that have been put alongside it. Before I took this role, I led AstraZeneca's machine learning platform strategy and took that from grassroots. Some of the achievements we put behind there was able to enable 300 plus machine learning projects through a large investment in platform engineering, but then also being able to deliver consistently developed machine learning for that pharmaceutical use case. Outside of that, I spent time working with AWS to create their machine learning specialty certification, but then also help them put together their exams, qualifications, and help them build out the learning material in the early days of SageMaker. I was very recently accredited with winning a clinical award for my contributions towards the AstraZeneca COVID-19 vaccine in regards to patient safety. But most importantly is I've spent the last 8 or so years building machine learning solutions on the cloud, including all 3 major hyperscalers. So to start with a little bit of an expectation setting about machine learning, I think these 2 quotes and stats give a really good understanding of where we see the business need in machine learning, which is that 74% of executives think AI will deliver more efficient business processes. I think that's fair enough to say. That's something we'll all agree with. And then 55% of those executives also think that AI will help develop new business models and the creation of new products and services. And I think that's, again, fair enough to see within current states of nation. We're seeing new products that haven't had a paradigm similar to them being entered into the market, and we're seeing new revenue streams being created around that. Now, these are really good high-level goals and excite people quite a lot, but when we jump into the reality of where machine learning actually ends up from a software engineering perspective, we'll actually understand that 85% of ML projects fail to deliver. And fail to deliver can be you didn't achieve your outcome, you did achieve your outcome, but unfortunately you weren't able to reproduce that. It might be actually you weren't able to produce any meaningful results, or if you did produce meaningful results, they were more expensive than the value that they generated. And then equally as worrying is 53% of all machine learning prototypes don't make it to production. And within the software engineering discipline, we pride ourselves on being able to build that production-first mindset, operational excellence. Now, I think everyone's probably seen this diagram. If you haven't, this is by a very clever machine learning engineer who originally started at Google, called D. Scully. This was one of the first hypotheses we led in software engineering to start to size the effort of different portions of the machine learning project lifecycle. And whilst I'll save you the fun and games of digging into what each of these individually are, the important thing that I want people to take away from this is actually This small red box in the middle is what most people will regard to as machine learning code. And this is the box that normally requires the machine learning domain to be successful. And actually, everything else that kind of sits around it is kind of IT management, data management, infrastructure orchestration, advanced configuration, setting up tools. And you realize that actually the machine learning model running in the center of this isn't the majority of the complexity inside a project. When we break that down even further, we can actually start to measure this that around 8 hours of machine learning engineering is normally dependent on about 96 hours worth of infrastructure engineering, 32 hours worth of data engineering, and 24 hours worth of feature engineering, with the majority of that time being set up getting your tools into the right order to run your PyTorch model or TensorFlow model. Again, another chunk of time being used to make sure that that machine learning engineer has all the data they need to be successful. And actually, if they don't, an iterative process to go back and go get more data. And then 24 hours of feature engineering, taking that data you've got and implementing business domain knowledge, taking subject matter experts and people who understand what that data means and being able to put some interpretation behind that data as well. And what you're really looking at is actually a ML project is an ensemble set of skills that normally are wider than the typical skill set a machine learning engineer will have. And when we ask people, what skills do you need to be successful in a machine learning project? It's very interesting when you ask the people in machine learning projects, and they'll list a huge wide set of skills from analytics, business, engineering, data, mathematics, and statistics. And actually what you really realize is that this requires a T-shaped jack of all trades type individual who will understand all these concepts and help bring them together, normally leaning on a couple of different people's expertise, where those expertise is in normally their own subjects in their own right and very rarely overlap. And no matter where you focus, if you build a really engineering and computing focused team, you're going to lack on some of the other parts to do with business skills, potentially mathematics. And if you focus on a really domain and business focused team, then you'll lack the engineering or maybe the data skills alongside that. This has become particularly interesting because you're seeing machine learning going from where it was typically associated with companies above 10,000 employees to actually the majority of the stake now being done in small companies below 200 employees. Some of the reasoning behind this is probably the explosion of, I think it was 85 plus is the final number I've looked at, for AI startups valued at over $1 billion in 2022, which I'm sure is something everyone wants to be a part of. But then we're also seeing this constant democratization of machine learning. The entry point for starting an ML project isn't in the hundreds of thousands anymore. It's actually becoming much more manageable, a much more smaller amount of capital to begin and raise. So much so, companies can start tackling that in their seed funding and Series A challenges. We're also seeing those types of one-person band ML projects come together where people are starting to maybe not build the most complex or widely applied machine learning models, but are building really accurate, powerful machine learning in a single place. Another element of this is we're seeing lots of the economies of scale that have typically been needed with things like hyperscaler clouds being broken down, things like serverless ML inference, things like acceleration using different types of hardware. And these are massively changing the economics of how these work and allow them to become much more accessible for smaller companies. Now, production's an interesting challenge, and actually I think it's still present amongst whatever scale of company you are. No matter what domain and expertise you seem to be hiring into your projects, you're still challenged by the same concept of how do I get my machine learning to be ran in that production mindset? How do I get people using it? How do they leverage it? If you can do that at scale in a really resilient environment as well, fantastic. But just getting the model into that status is becoming a harder and harder challenge for everyone. You're looking at about 42 to 45% of people deploying their models on premise. I presume the reason for that would mostly be cost savings, so you can get a higher degree of ROI on the infrastructure you own as opposed to rent on the cloud. Alongside that, you might also have use cases where that model might be a critical part of confidential data or PII. And actually, the cloud might not be where you're able to deploy that data. Having worked in pharmaceutical business problems alongside hospitals before, you'll really struggle to get some of that data into the cloud. You've got a good chunk between 20 and 25% of people saying we don't bother to deploy our models to production, and they're probably really struggling with the consistency of management alongside those models. Maybe they're having challenges with drift. Maybe they're also really challenged by some of the larger concepts around that, such as how do I make sure that workload is reproducible? You get a fair chunk of people deploying models to the cloud, ironically, not as much as on-premise, given the current direction of travel, but you still do see some models make their way into that end point. Typically, the comments that are associated with that is the pathway to get to production on that cloud is not the same as the pathway to get to production on-premise or on another cloud. So normally that's achieved via a series of abstraction layers. My favorite stat is the 5% of people who actually don't know where their machine learning model is being ran and don't know if that's determined to be production. And actually, I think there's some risks raised here around actually unmanaged production environments that, don't get me wrong, some of those are outside of regulatory and compliance use cases, but actually maybe those people who aren't deploying to production without an awareness of it can't gain the advantages of cost saving in those settings. And when you start to ask end users around what are the reasons why they're not making it to production, it's pretty much always the same. It's difficulty meeting security standards, making sure you can align to concepts like ISO 9001, making sure you're correctly using things like GDPR, PII data. The interesting one on the second point is actually securing the data connectivity. One of the challenges with machine learning is it needs good data. Good data normally has a large amount of consent required around it to be effective. Some of those parts of consent might have end users requiring that to be particularly secure or can't be used in certain circumstances. So actually, data connectivity and securing that workload alongside making sure that you're developed to the right security standards seem to be the biggest blocker to production. The next 2 points really dig into management of environment and in particular compute and programming environment. And I think we've seen that across how people are undetermined around the Python R, and most recently things like Rust and Golang coming into that space as well. Managing compute resources and access to compute resources, typically a common issue alongside that acceleration, whether you're in training or inference use cases. And then if you kind of look alongside that, it's moving to the cloud, model decay, data drift, and the typical problems you see in the ML use cases. Now, this problem might seem bizarre to the software engineers in the room because in software engineering, we're very good at implementing large-scale concepts like continuous integration, continuous delivery. We normally have a really strong golden path that actually the software engineering community can arrange itself around. However, in machine learning, you might get to the last step of this workflow, discover something which you would regard as good news, and that good news is you have to go back to the very beginning of your machine learning model and recreate from scratch because you've discovered rebuilding it in this way would give you X degrees of performance increase, or actually you can achieve the same outcome with drastically less data. And this exploratory experimentation cycle that you see people iterate around has no fixed duration. Quite often you will fail in machine learning until you failed to fail. And normally that would be the way that you carry that onwards to be able to come to a successful result. You can do all of that successfully, and actually the result you record at the end might not be good enough to be able to move the needle of your business problem or solve a challenge. Maybe it falls below what you could get a human to guess how that problem's solution to be. Failing fast is a critical part of this. You see a lot of agile methodology coming into place around how this can work. But the important thing is it's not a linear path, it has multiple points of failure. That's every single point to failure. And at any point you can backtrack and bring yourself to an earlier point in this development cycle. And normally the thing you gain in that is an insight to be able to go through the loop again in a more efficient way. With that already complex life cycle, let's talk about the tools people use to get from end to end of the life cycle. Now, this diagram should shock some people, particularly product managers or people who work across a large ensemble group of tools. But what this is effectively a highly opinionated and highly divergent set of standards, tools, technologies, and platforms where every single one has strong preferences that they would like to use this tool Also, some of them, well, all of them have strong preferences about people who had never used this tool. And actually, there are no providers or vendors here that got off lightly. The machine learning ecosystem is very commonly accommodated by multiple tools, often from different providers. The integrations between them commonly built by the end user who's orchestrating it. And in very few situations do any of these cover end-to-end the entire machine learning lifecycle. If you add things like preference, different types of domains and industries preferring different problem solving and model techniques and different modalities being more useful in different areas, this becomes a really complex area. And actually, just knowing what's on this list to solve your problem is hours and hours of reading that changes constantly on a month-by-month basis. With the wide state of fragmentation and abstraction in the machine learning ecosystem, we decided to look at surveys finding out what ML engineers actually wanted. And with resounding yes, the thing most wanted and sought after from machine learning engineers was more open source tools in the data science community. And actually, if you expand into that, it goes into different types of resources, infrastructure, and models that are provided alongside that. Only 6% of people surveyed actually cared about any innovation or improvements in vendor-provided products, which was really interesting. There is a lot of customers building on other people's products and then going the last mile with bespoke code on their own. Now, why do people want open source ML products? Well, normally they're better from a product quality point of view. They're normally more desired. And actually, I think the majority of people who are using platforms will always add different things from the open source community to their vendor or provided or proprietary platforms. ML lock-in is something people are really afraid of. And actually, if you think about it to that multiple pathways that users can iterate through in their journey, lock-in can be a brick wall, which can prevent the amount of options and outcomes you have to be able to achieve being reduced. It's also cheaper and it's quicker, is the final 2 points that get added onto that quite commonly. Two stats that I like to raise alongside this slide, which I think really showcase the gap of opportunity for open source and cloud native machine learning, is actually 65% of companies surveyed from Anaconda said they lacked the investment in tooling and technology to be able to run high performance machine learning or high quality machine learning in production. 87% of the same people who responded to that survey already leveraged open source technology. Now, the last 3-4 years, open source has led the portions of the machine learning ecosystem and in fact actually done really well to make sure that they have stayed relatively unopinionated and wide-reaming. That's obviously introduced a lot of different options for tooling, but actually it's fair to say that open source machine learning has been ahead of where a lot of proprietary tools and platforms have been, and the acceleration behind that has been exponentially increasing. So here at Civo, we position ourselves very much in a developer-first mentality. We think a lot about cloud native and how we give back to this technology and the community that's surrounded in the technology. And we also think very differently about trying to not walk the path our competitors have the first time around. What we're trying to do with our machine learning ecosystem is instead of building more proprietary tooling, there's a famous XKCD comic about having 11 standards and saying you're going to bring them all together and introducing a 12th standard. But actually what we want to do is invest and expand that cloud native ecosystem and not build more barriers to adoption. We think that's really important from an interoperability point of view and actually being able to leverage some of the large scale accelerations and cost savings behind that are all cloud native concepts that we think can be really disruptive. We don't think the right thing to do is continue to build another pathway or another golden path alongside that. And actually, we think that there's a very important job to be done on bringing all those pathways together and starting to tie them together in the middle. Interoperability allows people to take more problem-solving pathways, allows more technology to connect into it, and thus build a bigger ecosystem. And then one of the things we're really passionate about is how we can actually lower the barrier of entry for machine learning. Right now, we think that the current costs to get involved in that aren't quite as appropriate for small players and startups. And actually, we are eager for people to be able to leverage that in a way they don't have to re-educate or retrain themselves. Learning some of the hyperscaler machine learning platforms end to end can take months and months. And that's something I'm quite confident on for my involvement in. The first product I'll be talking about today is our Kubeflow as a service product. This builds upon a really strong open source contribution that came originally from Google, but has been backed by a large degree of enterprises. And it's actually, Kubeflow is one of the very few machine learning platforms that can go end to end across the entire life cycle in an open source way. Kubeflow is the best of breed of different machine learning tools from the Kubernetes landscape, all built into a single developer workflow. And what we're particularly excited about is that this can be a zero configuration way of people getting involved into a very cloud native focused machine learning ecosystem. But then also you can go from having a company with no machine learning tools to spinning up every tool that a data scientist or machine learning engineer will need, from experimentation to training to pipelines to inference, in less than an hour. And we think that that's a really disruptive proposition for companies who want to make their first venture into machine learning without breaking the bank, without getting lost in all the technical complexity, and most importantly, without losing any autonomy in solving your problem. We want to try and make this accessible to companies between a startup level, but then also scale to large enterprises. And we want to build on the existing strengths of Civo with transparent pricing. We're backed solidly by Defense.com's security, one of our sister companies, and actually have done a lot to make sure that you can just take your mindset off the worry around what's happening there with machine learning driven at scale. We're obviously contributing back alongside all these fantastic players. We're very, very aware that the recent Kubeflow survey talked about running and operating Kubeflow at scale on the cloud being one of the big challenges, but then also education and documentation alongside that to help break down the barrier of entry and smooth the learning curve for Kubeflow. Those are two areas we're really excited to start to get involved with and contribute back. And obviously, similar to the other open source ethoses we have with other Civo platforms we run, we're excited to start to give some of that back to the upstream GitHub Kubeflow project. This all fits together with the existing tooling. If it doesn't, you're very welcome to bring your own, because we believe in this being entirely interoperable with anything that you can connect to it in the normal Kubernetes mentality. We're launching with a public beta from actually KubeCon Europe in a month and a bit's time, and extremely excited to be able to demo some of that stuff at KubeCon this year as well. Please come find me on the Civo stand if you'd like to have a chat about it. If not, reach out via LinkedIn, the usual channels. Something alongside that, if you're not looking for as managed of a solution and actually someone who prefers to roll their own solution behind the scenes, we're really excited about launching GPU edge boxes that will accelerate not only just edge machine learning compute use cases, but then also hybrid and on-premise implementations using all the great Civo implementation we have currently. We've got some very disruptive GPU instances that are positioned in a very transparent but then protected and services added on functionality. And then also fractional GPU use instances that we're really excited about using to start to break down the entry cost for machine learning. And actually, if you're a company who's not ready to run an entire graphics card hot 24/7, then we have options where actually even with as low of 25 to 30% GPU utilization, you can start to rent just that segment. And we'll work with you to help scale as a customer up to that larger scale machine learning point. What we think is really important is having these entry points start low and then growing with you as a customer and provider together. These are very much so coming soon. We're really excited about any input and different types of ecosystems here I think can benefit in these tools in different ways. We're extremely open and receptive to feedback as well. We recognize how diverse the problem solving in machine learning can be, and I'm more than happy to take on any direction there and think about the problem in a large way. 3 direct call outs at the end of this presentation. The first is that if what I've spoken about today interests you, inspires you, is something you want to be a part of, we're extremely excited to offer private beta registrations at the URL below. But then also, if you run a data machine learning product that you think would be worthwhile us partnering with, or even if you just want to sit down about what we're doing in the cloud native machine learning space, please reach out to us at this URL. We're trying our best to build a really strong community behind us as we keep moving forward. A large part of that is obviously being connected to you all. The second call out I'll put across here is actually for Civo Navigate. I'm wearing one of the t-shirts for our conference. We had one Q1 this year in Florida that went down extremely well. We had fantastic keynote speakers such as people like Steve Wozniak, but then also some fantastic talks and presentations from people from across the cloud native ecosystem. As some shameless self-promotion, we're running another one of those in London on the 5th and 6th of September. Be great to see everyone there. We've got a fantastic venue and actually some really interesting speeches and conversations around what we're doing with the cloud native ecosystem there.
Awesome. Thank you for that.
Yes.
So we do have some questions.
We do. And just up front, we will mention again that all of these talks have been recorded, are being recorded, and everything will be on the kubecrash.io past events part of the website. You can see the first 2 Kube crashes and all the talks there, and you'll be able to see all these talks very shortly. So yes, thank you. That's been probably the #1 asked question. So obviously the content is good enough that people would like to have a second visit with it. So thanks, Josh, who has muted himself again. But we're going to need you to unmute.
You have to keep talking. So okay.
Yeah.
First question for you that somebody has asked, Dinesh has asked. There has been a huge growth in the general public knowing about ML with OpenAI. Where can people get started with ML as a career path?
So I think that's a really good question, actually. And there's loads of different entry points for people getting started with different machine learning skill sets. The way I really encourage people to get started is take something you really know and understand, like a problem you care about. It can be something as simple as setting up a Raspberry Pi in your house that just monitors your temperature, and then use that to like tune down your local home heating and start to build those really simple problem use cases, get used to building some machine learning models and deploying them for a very simple use case, and then start to scale that up. I think there is a bit of a gap right now in kind of like open, accessible, free content in machine learning. And I think it's really good to see lots of people putting space out there. But I'd really recommend the kinetic, get hands-on practical application of machine learning, and then talking to lots of people about their very different problems and the way that they use machine learning very differently, and starting to understand the breadth of the landscape.
Awesome. All right, I have a few other questions for you. There's one question. Getting started with GPUs in the cloud are really expensive. Is this due to constrained supply? Is it expensive to run? Or is this being a new high margin product?
GPUs are a really interesting piece. Every 3-4 years, someone brings out a GPU that has like 10 times more capacity and can run 3 or 4 times as much workloads. That's great for people who are at scale and running large scale data centers. It's actually locking people who have very small GPU utilization out of the market. So if you run your company and you only use 20% of an NVIDIA A100, and then someone brings out a fantastic new GPU that's got 10 times more capacity, you're actually drastically increasing your run cost by stepping up to the next layer and not utilizing it all. We're really excited to start to offer fractional GPUs that let people break that down and start to grab onto some of those kind of easier to achieve ROI baselines. Mm-hmm. But then we also think there's a lot of benefit there in starting to work around kind of like batching your model together and looking at slightly different paradigms of compute to be able to leverage that.
Okay, cool. Another question we have is, are there any CNCF projects people can use to bring business value quickly?
Oh, that's a dependent.
That's a very open-ended question.
I think there is a really interesting component there where it's not about necessarily CNCF owning a machine learning toolkit or owning a machine learning platform, but actually the auxiliary technology that has to be put alongside that. Something I think is a really big gap, which is quite interesting, is things like citizen data science, and actually how you can build a tool where a very clever person can be building a model with machine learning and PyTorch here, But actually someone who's completely non-technical, who's probably on the ground with the customer or collecting data, can input into that model. I think there's some really good use cases there around like image annotation, maybe audio annotation as well. They're good intersections where ML is dependent and needs to build on those skills and need to bring people into those projects, but maybe the technologies and solutions are a bit geared towards ML engineers, not business domain experts.
Okay, excellent.